Most AI demos work perfectly until you put real users on them. Then everything breaks. Model timeouts happen, APIs start failing, rate limits hit randomly, and the worst part about this is that your system does not crash. It just stops working suddenly. Jobs get stuck and responses never come back. Users retry manually, and this actually makes this whole situation worse. That's where most AI apps actually die. So I stopped thinking of AI as just an API call and started treating it like a distributed system with failure at each steps. What I mean is that we developers tend to think about only the happy path, that everything is working properly, I'm getting output, my job is done. That's not how it works. I made sure that each step I'm making, I'm thinking that okay, how this can fail, how I have to handle the error, which errors can come. I made sure that if the system goes away from the happy path, I know exactly why it went there. I know exactly how to solve this. And I made sure that every error I should know about. It should not be like, okay, out of the blue error happened and I don't know anything. That should not. This is how a reliable system should be built. And mostly reliable systems are pessimistic. Like they don't trust the happy path. So here's what that exactly looks like. See, even the best models will fail. They will fail unpredictably and you can't do anything about it. You will see partial responses, you will see empty responses. Delays will be very long. Like, for example, you just made a request. Delay was 1 second. Next time you made the request, delay might be 10 minutes. That's how random they are. And random errors are going to occur and they won't make any sense to you. So every AI call in my system has a timeout, has a retry strategy, and has a fallback behavior. That okay, if everything fails, this is the behavior you should fall back. Like this is the default behavior. Now we are at the layer 2, which is rate limits. This is the silent kill. Everything works fine until traffic spikes. Then suddenly requests start failing random. And honestly, I personally have faced this issue more times than I would like to admit. Retries is not the solution in this case. It actually amplifies the problem here. Queues will explode. So what I did was I throttled requests before they hit the mark and I put everything in the queue. So I made sure that frontend is not directly calling the model. Frontend is putting the request in the queue and then model is picking requests from the queue and processing it as it sees fit. Then we have a retry strategy. See, naive retries are dangerous. If you retry instantly, you are just DDoSing your model API. So I used smart retries. I used exponential backoff. I capped the number of retries and I used idempotent jobs, meaning that if something fails, it retries gradually, not aggressively. For example, okay, you have a request. It failed one time. It will wait for some time. Then it will process it again. If it failed again, it will wait for some more time and then it will try again. If it failed like n number of times. N can be anything. Let's just say 4. It failed 4 times. I made sure that it is not retried again because I have capped the number of retries on a particular job. That okay, this is the job. I'm only going to retry it 4 times, and each time I'm going to make sure that when it was retried and when it is next going to be retried, there is a significant time gap. So I made sure that okay, retries should be capped. I'm not going to just ask the model with infinite number of retries. Now, fourth is the dead later jobs. See, some jobs are not going to succeed no matter how many times you are going to retry. Let's be real about it. Because sometimes what happens is that some jobs are inherently wrong. For example, let's just say anything like user credentials are wrong. So this job should never be processed and this job will never succeed. So no matter how many times you are going to retry. So if you don't isolate them, what will happen is that they will block your entire pipe. So after a few failures, the jobs move to dead letter queue. Dead letter queue is nothing. It's just a database storing that, okay, these are the jobs that retried for maximum number of times. There was no solution for it, and now they are stored. These we use in error detection and see if there is something model is doing wrong or our system is failing some. Now, what is the benefit of this? Its benefit is that system keeps on running and failures are isolated. So I can easily inspect them later. So it is very good in failure inspection, and the system also keeps running after this. Fifth is your observability. This is where most developers completely mess up. Just think about this. If you don't even track your own failures, how would you even know that whether your system is broken or not? So I tracked everything. I tracked job change status, that how jobs are going from pending to running to failed or completed. Then I checked, okay, how many times we are retrying everything. I checked the failure reason. I checked latency. Basically, I made every AI request traceable. I made sure that if any error occurs, I just have to look at the logs and I should know exactly that this is a piece of code I need to work on. Now let's go through a complete system flow. Let's just say a user uploads a resume. Here's what actually happens behind the scenes. In first step, the job gets added to the queue. Then the worker picks it up and calls the model. Now imagine if the model fails. Instead of crashing, the job is retrieved after a delay. System logs the failure and user still sees it processing. If it fails again, retry count increases, delay increases, and if it keeps failing, it is moved to dead letter queue. Meanwhile, everything else continues to work. There is no stopping for you. Finally, when like if it is moved to dead letter queue, the user status will change from processing to failed. But up until then, it is not failing for any other things. Like user can do any other processes he want to do. For other users, it is not failing. So failure is isolated and system is not affected by the failure. This whole setup, but is not free. Like you have to still pay for it. You are trading speed for reliability. See, what happens is that from front end, calling the model is the fastest because there is only one step. You are just calling the API from the front end and okay, you got it. But what happens is that when you are building this whole system around it, you are trading the speed for reliability and simplicity for control. Because from front end to model, it's a very simple thing, just one function call. But when you are building everything like this, you have to make sure that okay, different components are reacting properly, their communication is working properly. So you have to like this becomes a complex thing. So queues add latency, retries add complexity, and observability adds overhead. But without everything, like without these things, your AI app only work in demos. It is only good for demos. So if you're building an AI system and it depends on a model, it's very unreliable. Like because see, even the perfect of the models you can find, they are prone to failures. The only question becomes is that did your design for failure or not? Whether your design can handle a failure or not. If you're building real AI systems, this is the layer that actually matters. Because model calling is very easy, but the systems around this model call, how you're going to handle failures, how you're going to handle randomness, is the key thing that makes the project or the app or your SaaS product worthwhile.